In this video presentation, FreeSBC on AWS is configured to enable traffic between a SIP trunk and a FreeSWITCH server. Note that FreeSWITCH is shown as an example, but it is important to note that the configuration process is virtually the same for all soft switches or IP PBXs. This same process also applies to ProSBC. The process to configure an SBC consists of a series of steps. They are configuring an IP interface, creating a SIP stack, creating a transport server, creating two network access points, creating a DNS group, creating routes, verifying the configuration, activating the configuration, and making a test call. This tutorial will guide you through these steps. In this phase of the process, the web portal is used to create an IP interface. In this scenario, the IP interface is already pre-configured on the AWS instance. If you are installing the FreeSBC on another virtual machine, you will need to create the IP interface. The IP interface menu is shown for illustrative purposes only. Access the SBC web portal with the web browser using the IP address and port 12358. Then enter your username and password. The web portal welcome page is displayed. Click IP Interfaces. The IP Interfaces page is displayed. On this page, current IP interface names and their setting values are displayed. To create a new IP interface, click Create New IP Interface. Mentioned previously, IP interfaces are pre-configured on the AWS server. However, if you were to create one, give your IP interface a name and set other values as required. To learn more about these settings, consult the TelcoBridges TV Wiki. In this phase of the process, a SIP stack is created. This enables you to configure SIP signaling. In the video, a name is supplied and all other settings are left at their default values. To create a SIP stack, click SIP. On the SIP page, click Create New SIP. Provide a name for the SIP stack and leave all other settings at their default values. Click Create. In this phase of the process, a transport server is created. This is used to transport SIP traffic. The previously created SIP stack requires a SIP transport server. To create a SIP transport server, click Create New Transport Server. Provide a name for the transport server. Select the port type and IP interface, then click Create. The results page is displayed. In this phase of the process, two network access points, referred to as NAPs, are created. These NAPs are the SIP traffic entry points to the SBC for SIP traffic. One NAP is created for the FreeSWITCH server and the other one is created for the operator SIP trunk. To create the first NAP, click NAPs to access the NAPs page. Click Create New NAP. In this demo, FreeSWITCH is entered for the NAP facing FreeSWITCH. Click Create. Select the previously created SIP transport server. Select an IP port range. Enter a proxy address. Click Save. The network access point appears in the list. Create a second NAP in the same way. Give it a name. In this demo, SIP trunk is entered for the NAP facing the SIP trunk. Click Create. For this NAP, an FQDN is entered for the proxy address. In the next phase, a DNS server will be created to support this. Click Save. The second NAP is displayed in the network access point list. In this phase of the process, a DNS group with a DNS server is created to support the FQDN that is used by the previously created NAP. To create a DNS group, click DNS. Click Create New DNS Group. Enter a name for the DNS group. Select an IP interface. Create a new DNS server for the DNS group. Enter a name for the DNS server. Provide a server address. Click Create. In this phase of the process, routes are created to form connections between the NAPs. One outgoing route is created to serve the outgoing calls from FreeSWITCH to the SIP trunk. One incoming route is created to serve the incoming calls from the SIP trunk to FreeSWITCH. To create the route, click Routes. Click Create New Static Route. In this case, to SIP trunk denotes the outgoing route from FreeSWITCH. Select the FreeSWITCH NAP. Select the remap NAP, which is in this case SIP trunk. Click Create. Create a second route in the same manner as before. Provide a name for the incoming route to FreeSWITCH, in this case from SIP trunk. Select the SIP trunk NAP. Select the remap NAP, which in this case is FreeSWITCH. Click Create. The two call routes are displayed in the routes table. In this phase of the process, the configuration settings are verified. It is important that this verification is done before activating the configuration. To validate the configuration, click System. In the Validate Configuration window, click the Validate button. The results of the validation are displayed. In this case, everything is green and successful. In this phase of the process, after having ensured that the configuration settings are good, the configuration is made active. To verify the configuration, select System. In the Activate Configuration box, click Activate. In this case, we are using a working configuration for ClueCon. The activation status is displayed as successful. To view the status of the NAPs, for example, click Status. Click the Status tab. Click the NAP tab. The list of NAPs are displayed and all of them are shown in an OK green status. In this phase of the process, a test call is made to test out the configuration. In this scenario, a call is made to a telephone number that is one of the direct inward dial lines on the SIP trunk. The call trace feature enables you to see that the call completed successfully and detailed information about the call is displayed in the call trace menu. To verify the configuration work, click Call Trace. The search box by default is set to search the 24 hours of the current day. Click Apply. Search results are displayed in the list. In this case, the SIP trunk to FS1 route is displayed. The details of the call are shown as two call legs. One for the FreeSWITCH NAP and the other one for the SIP trunk NAP. Select a call leg to display the details of the call.